Yeah.
Okay, so in this problem we have a truss. You can see all the dimensions. Each of the spans are 20. It has a height here of 30. And we want all the forces in the truss. So we're going to use this as an opportunity to try all of our different techniques: zero force members, method of joints, method of sections. So I can write down quickly any zero force members. We talked about this previously, but you can see if you examine the system, only joint G provides one of our zero forces. In fact, if I wrote it down, I would say that in our accounting, we call that case 2. So based on that, the force in BG is 0. Zero force member. So that was easy enough. And what I'll do is I'll make a little tick mark through it, but I know we've got that one. Now, what does case 2 also tell us about AG and GF? They're equal. So let me go ahead and write that down. So I don't know the value yet of AG, but I do know that if I find it, it's going to be the same thing as GF. So that's not so bad. So that means of the 11 unknowns, I have one, and I have a relationship between 2 more. So I really only have to find 9 things so far.
Only 9?
Only 9, yeah. It's a good number, 9. So how should we start? What's the first step?
Reactions.
Yeah, let's get the reactions. I think that's a good place to start. So A is a pin. So I'll assume that I have AY acting up, AX to the right, and then a reaction at E also acting up. And let's find those reactions. So to do that, I'm going to sum moments at A and find EY. And then some forces in the Y direction get AY. And then some forces in the X direction and get AX. And looking ahead, you can see there are no X forces on the structure, so AX probably is going to be 0. So I'm going to use right-hand rule as my sign convention. So I will sum moments at A. Make sure it's in equilibrium. So when I do that, all the applied forces are going to create what kind of moment about A? Positive or negative? Negative. So I'll just go down the list. So I have 6 kips times 20 feet minus 6 kips times 40 feet minus 3 kips times 60 feet. So that should get all my 3 forces. And then EY is going to create what kind of moment about? Positive. And it has a moment arm of 60. So what's EY equal to?
9.
Say again?
9.
9, exactly 9. Anybody else get that? I hear 2 yeses. 3? Yes. Excellent. 9. That's a good number, 9. So let's sum forces in the Y direction, and we should be able to get AY. So I have AY acting up, and I have my EY also acting up, and then my 3 forces acting down. So that's minus 6 kips, minus 6 kips, minus 3 kips. So it looks like AY is 6. You guys get that? And then this is a little trivial, but we'll go ahead and sum forces in the X direction. Make sure we're in equilibrium. The only force in the X direction is AX. So it's 0. So we have all our reactions. Now where to begin? A lot of different places you can go. Let's just, for discussion purposes, are there any places we can do method of joints quickly and get some results? Yeah, A is a good spot. I have 2 unknowns there. I can get those 2. I could even jump up here at D and get those 2. What else could I do? That's pretty much the end of it. All the other joints have 3 or more bars acting through them. So we can't really do anything there. What about method of sections? Could I cut a method of sections here? Sure. Could I do one here? Oh yeah. Could I do one here? Sure. We got lots of options. So let's just start with joints. So we'll start with joint A. So there's the joint. I have my AY reaction, which is 6, and then I will assume tension in AG and tension in AB. What is the slope of AB? It looks like I went 60 to 30, so it's 2 to 1, right? 2 horizontal to 1 vertical. So, trying to write one equation and one unknown, what should I do first? Sum forces in the x or sum forces in the y? Well, they both have x components, so that's probably not a good start. So we'll sum forces in the y. So summing forces in the y direction, make sure we're in equilibrium. What do I have? Well, the y component of AB is the hypotenuse would be the square root of 5. So it would be 1 over the square root of 5. AB. That's acting up. And then we also have my 6 kip force acting up. So what is the force in AB? It looks like it has to be negative and whatever 6 times the square root of 5 is. Don't say 13. I have tristodecaphobia.
13.4.
I told you not to say 13. What is it, 13.4? Anybody else get that?
It's 12 plus 1.4.
I like that. 12 plus 1.4. Anybody else get that? Yes? Okay, great. And it came out compression. Does it make sense that AB is in compression? Well, kind of look at it. I got all my loads acting down, so you expect the bottom chord to be in tension and the top chord to kind of be in compression. So that seems okay. So now that I have that, I can sum forces in the x direction. I'll assume to the right is positive. So I have the force in AG plus 2 over the square root of 5 of the force in AB. And that's it. So I should be able to solve for the force in AG. Looks like it's going to be 12. And it's going to be positive. You guys get that? 12? Anybody else get 12? Excellent. And since we know AG, we know GF. Right?
Just to be
Tick,
clear,
tick, tick.
when you wrote plus 2 over square root of 5 FAD, you plugged in a negative 13.4.
Correct. But when I wrote my equation, I looked at my original free body diagram. They're both to the right. So I wrote my equation. Then I looked at the equation. Do I know any of these values? Yes, I know AB. What is AB? Negative 13.4. So where you get into trouble is where you come up here to AB and you say, hey, this is negative, and you try to go back over here and redraw AB. I highly discourage you from doing that. It gets you nothing. It takes time to go back and mess with your diagram. And remember, on the exam, time is your most precious resource. Don't waste it. So don't do that. Save your wasting of time for something else. But not that. Hey, we're doing pretty good. Look at all this is gone. Pretty good. So what else should I do? let's stick with method of joints one more time and go up here to D. Now you don't have to do this, but right now you have a little more experience with method of joints, so let's push it as far as we can before it breaks. So here's my connection at D, and I have a force in DE, and I have a force in CD, and of course I have my applied load, which is sitting on top, which is 3 kips.
Can I ask you why you decided, why you chose D?
2 unknowns. Right? Method of joints, you have 2 unknowns you can apply, and I wouldn't have to include right now any of my other calculations. You see, D is out there all by itself. I don't even have to include reactions in it.
Okay.
So if I've made any mistakes up to this point, they will not propagate into my calculations at D. Let's see, the slope is still a run of 2 to a rise of 1. So in the similar methodology that we talked about at joint A, looking at this, you'll notice that in this case, my 2 forces both have Y components, but only one has a X component. So I would sum forces in the X first. So let's sum forces in the X equal to 0. So what do we have? We have the X component of CD. It's to the left, so that's negative. And it would be 2 over the square root of 5 is the X component of CD. And nothing else. So what does the force in CD have to be equal to? 0. Now, you know that jet commercial where your head blows off and the purple smoke comes out? Do not emulate that now. Why is this so bizarre a result? It's not. With this load at D, all the force is being transmitted directly into this vertical member. This horizontal guy here is not doing anything. But it's still there for stability. Okay? I like that commercial. You guys seen what I'm talking about? I think Jet got bought by somebody. They're no longer independently owned. I think Walmart. The beast grows larger. Anybody affiliated with Walmart? I guess if you were, you wouldn't be here. You'd be in Arkansas somewhere sitting on stacks of gold. Okay. So some forces in the Y direction, what do we have? Well, do we even worry about CD? No. So I've got the force DE acting down and my 3 kip force acting down. So it looks like the force in DE is -3. And what does negative mean? Compression. Does it make sense that this element with that load applied would be in compression? I think it does. All right, so let's tick those 2 off. So really we're down to 1, 2, 3, 4, 5 things. We're about halfway there. Now might be the time for a juicy method of sections. I'm not sure where the best method would be, or best section would be. I'm not sure. Obviously, I could cut through here and find these 2 guys. I could cut through here and find these 2, and I'd only be left with this guy. You can even cut a section this way and get that one if you want. So it just depends on what you want to get out of it. So I'll let you guys decide. What do you want to do? Here, we'll send it to a vote. Since it's the election season, you guys are all millennials. Oh, you're not going to vote anyway, so I shouldn't do that. Right? You know what I heard? The poll? You don't care? It's okay. I understand. I was young once. It was a long time ago, but I was young once. So let's say this is section 1. Who wants section 1? Raise your right hand. Nobody. Excellent. Who wants section 2? Raise your right hand. 1, 2. Oh, everybody wants that one. Great. You just wanted to let the first one go by, right? So we're going to cut it there. I'll just call it section AA, just for keeping track of it. Do you now want to work the left side or the right side?
The right side.
The right side. So let's do a free body diagram at that section AA. And you want the right-hand side. Well, I maybe drew that a little too big. Okay, so we know what EY is. What is EY? We solved for it. It's 9 kips. We know we have a 3-kip force applied at the top here. And I'm going to get my force in EF. My force in CE. And my force in CD. Now we already know CD, right? In fact, I'll go ahead and circle that to indicate that we know that one. So it's just these last two that we have to deal with. And the slope of this particular element is 20 to what? If this is 30, then this is going to be 20, and this is going to be 10. So it looks like 20 to 20, so that's a 1-to-1. If you did care for this one, we've already looked at that. That's the one that's 2-to-1. Now looking back, remember CD is 0, so really I don't even have to worry about it. In fact, I'll just go ahead and say, we don't want to deal with it. So I just have these 2 remaining unknowns. How should I get those? What if I sum moments at E?
So that counts as both of them.
That doesn't really help me. Is there some other place I could sum moments and help me?
Around C.
One equation, one unknown. C? So let's see if I can extend that. So if I go up here to here, that should be point C. So that's a good idea. Let's sum moments about C. So my right-hand rule, we'll sum moments about C, make sure it's equal to 0. Now about C, what kind of moment does EF create? Positive or negative? Negative. So the force EF, and what's the moment arm from C to F? That's this distance. That's 20. Okay, I took care of that. Oh, what about the 9-kip force?
Positive.
Positive. And its moment arm is the span from C to there, which is 20 also. And don't forget the 3-kip at the top, which creates negative. Also at 20 kips. Did I leave anything out? You divide everything by 20, it looks like the answer is going to be 6. Does that make sense? You guys check that for me? So now how do I get CE? You could sum forces into, it doesn't matter. Remember, this guy's out. So if I want to get CE, I can sum forces in the Y or the X, but X would be less work. I don't have to worry about my 9 and my 3. Could I get it by summing moments somewhere?
Yeah, some moments around here. Would that work?
About where?
D.
B?
D is the moment.
Well, let's say that again. We're trying to get CE. So really, anything on this line of action that creates a moment That would eliminate EF and allow me to calculate this one, right? What about F? Would F work? What if I sum moments about F? What would I get? Well, EF passes through F. This one is 0, so I just have CE and then these two forces. How do I find the moment of CE about F? Well, remember that force exists anywhere on that line of action. So I can move it anywhere I want up and down this line of action. What if I moved it down to here? Then I would have what? A y component and an x component, right? And only the y would create moment. So if I take the y component times this distance, that would be the moment. You guys see that? You could also slide it up to c if you wanted to, and then only the x component about f would create moment. Just depends which one you want. Since I didn't leave myself enough room to draw that, I'm going to go the other way and come over here. So the y component is going to be 1 over the square root of 2 of FCE. So if I sum moments about F, what do I get? Well, about F, my y component creates positive moment. What's the moment arm? 20. And then what else creates moment? The 9 kip and the 3 kip. Now they're both on the same line of action, so I could take their equivalent force, which is really 6 kips up, and that creates what kind of moment about F? Positive. And what would its moment arm be? 20. Well, I really feel the energy in the room diving rapidly. Are you guys following along with this? Are you just so completely bored out of your minds that you're just numbing over? No one wants to vote for either one of those options?
We're talking about politics.
Oh, I bought the whole room down when I brought in politics. Sorry about that.
Normally when I start moving points to take some moments, I just go either in the X or Y, because I start getting confused. Well, I'm not going to say confused, but it takes me longer to dissect everything going on.
I just want to show you a possible other way. The cool thing about this is the 20s cancel, and the force in FC, if you calculate it, it's just going to be square root of 2 times 6, which should be 13.4, I'm guessing. But I'm just guessing. What'd you guys get? What's 6 times the square root of 2? Yes, 8.5? Anybody else get that? Why don't they say 13? My Rain Man is off. Okay, so let's go back and see what we've got now. So I got this one and this one. I still have 3 to go. This problem's going to take forever. So what should we do next? I'm going to cut another section since we're talking about sections. I'll call it section BB. And I'm going to work the left-hand side of that one. And that's about all the time I'll have for today. I'll have to let you guys finish it up. So in that case, our free body diagram looks something like this. So the applied forces are my reaction at A. In the y direction, that is 6. And I have a 6 kip at B. And then I have my forces. The force in FG which actually we already have, the force in BF, which we don't, and then the force in BC, which we need. So I'll go ahead and circle this one because we've already solved for it. Remember, GF was equal to AG, and AG was 12, so I know that value. Oh, it's off the bottom of the screen. Sorry about that. So what should I do? Yeah, summing moments about B is not going to be a good idea because it eliminates the two I don't know.
Can you do it at
F? F. Yes, good idea. Let's go to F. Why is F a good spot? Yeah, BFFG, so I should get this guy. Now, you have to decide how you want to deal with this. So what I'm going to do is I'm going to go ahead and sketch this in and show you that BC on its line of action would extend up to B and would have a horizontal component and a vertical component, right? And again, about F, the vertical component would create no moment, but the horizontal moment or component would. So if I now sum moments about F, make sure it's in equilibrium, I have to deal with this 6 kip force, this 6 kip force, and the horizontal component of BC. If you remember, we've already done this a couple times. This is a 2-to-1. So the horizontal component would be 2 over the square root of 5 of the force in BC. And it's creating negative moment about F with the moment arm of this distance, which is 20. The 6 kip force creates positive moment and a moment arm of 20. And then this 6 kip creates negative moment with the moment arm of 40. So from that, you should be able to find BC. It looks like it's going to be negative. I don't know what the value is. You guys will have to tell me the value. Three times the square root of 5. I'm guessing. We'll stop when this is done.
6.7.
6.7. Anybody else get 6.7? Not 6666.7? Okay, cool. Just wanted to check. All right, so we'll stop here. It's been 29 minutes working on this problem. So let's see if we can make something clear. What's the probability of this appearing on the exam? 0. The same as you winning the lottery, which is near 0. So, but a portion of this is testable. For example, if I just asked you what these 3 forces were, do that. If I asked you what these 3 forces were, you can do that. Okay? All right. We'll stop here.